Hello, and welcome to this episode of Madison's Chemistry. Today we're going to be going over a few kinetics practice problems. And throughout this video, I encourage you to press pause and then solve the problem and press play when you're done with the problem. Okay, so now we're going to go over this first question here. It's a little bit different from the previous question that we've gone over in a different lecture, because now we're going to take this one step further and we're going to be solving for K. So the first step is we need to first determine the rate expression. So we need to know the rate orders. So we're going to say that rate is going to be equal to K times A times B to the power of M and N. Those are our rate orders. Okay, so I'm not going to go into too much depth about how to find this because I already have a video going over that. So I'm just going to look and see here that when we hold A constant and double B, this doubles. So therefore, B is first order. And then when we hold B constant and we double A, it doubles also. So that's also first order. Okay, so we have our rate expression. And so now all we have to do is just plug and chug. So it's pretty simple. So we're going to take the rate, and in there we can just plug in any of our three columns. So we could plug in all the values here, here, or here. I'm just going to do the first one. Okay, so we know that the rate here is 1.1 times 10 to the negative fourth molarity per second equals K times the concentration of A, which is 0.03 molarity, times B, which is 0.03 molarity. Now, if this was second order, and this was actually raised to the power of 2, then when writing out this expression, we would put that to the power of 2, but it's not a second order, it's a first order. Okay, so now we can solve for K, and we'll get 1.1 E over 4 divided by 0.03 squared. Okay, so we'll get K equals 0.122. When attempting to solve this question, I think it's valuable to ask yourself, what is this question actually asking me to solve? So it's asking for the rate at which B and C are formed. So that's going to be the rate of appearance. Okay, and what it's giving me is the rate of disappearance of A. So I'm gonna think back to the equation that's gonna relate everything together, and that is going to be the one that says if we have something like this, assuming that the lowercase letters are the subscripts or the coefficients in front of them, then we could write an expression like 1 over A, negative 1 over A times the change in concentration of A as a change in concentration of time is going to be equal to rate of appearance of our two products. Okay, and when we're talking about rate of appearance, that's this thing here. Rate of appearance and this whole thing is just known as like the rate of the reaction. So the rate of the reaction for each of these is equal, which is why we have all these equal signs. But the rate of appearance or disappearance are not equal. Okay, so now let's go ahead and get ready to set up this problem. Okay, so we know that we have negative 1 over, okay, so let's look here and see that, okay, our coefficient of the concentration of A is 2, so it'll be negative 1/2 times concentration, or the rate of disappearance. This is just the rate of disappearance. So that is just this whole thing that it gives us. Okay, so we'll plug that in. 4.4 times 10 to the negative third. Okay, so I think it's useful to first figure out what that even is. So 4.4 negative 30 divided by 2, we'll get it equals 2.2 times 10 to the negative third. That's the rate. Okay, so then when we're solving to figure out what the rate of appearance of B and C is, we can set it equal to this. So we'll know that 2.2 times 10 to the negative third equals 1 over B, the coefficient of B, times, we can call this RB, rate of appearance of B. Okay, so this is what we're solving for. So we can scroll back up and see that there's actually a coefficient of 4 in front of B. So we get 2.2 times 10 to the negative third equals 1 over 4 times rate of appearance of B. So if we multiply that by 4, we'll figure out what that rate of appearance is. And we'll get equals 8.8 times 10 to the negative third. Okay, and then we can repeat this with rate of appearance of C. Rate of appearance C, so we'll get 2.2 times 10 to the negative third was 1 over, we'll see that the coefficient of C is actually just 1 times rate of appearance of C, so that means that just the 2.2 times 10 to the negative third is equal to the rate of appearance of C. So in this question, it was really important to be able to distinguish what everything that was given actually means, right? If it says it disappears at a rate of this, that's the rate of disappearance, we have to remember how that applies to this formula. So I think that's probably the hardest thing about this question, is just figuring out what each of those things that were given means in relation to this equation. So I hope that this was good practice and that it's going to help you when you encounter future problems like